Hello everyone. So till now we have discussed about the SKU, how the SKU is behaving in terms of the setup and hold violation. So if we will decrease the SKU, there are chances of setup violation. If we increase the SKU, there are chances of hold violation. Similarly, we have also discussed that if SKU is less than our data part delay in the sense clock to Q and Q to D6 delay. So if skew is greater than this data part delay, the circuit is functioning wrong. So now in this lecture, we will talk about let us suppose that in your circuit there is a setup and hold violation, and you want to fix that setup and hold violation with the help of the skew. Then what are the different ways to do that? What are the recommendation we have for doing that? If whether there is any complexity with the such method, and if there is a complexity, that how it is going to impact our final design. We will also discuss in a general design technique why we are not referring, we are not recommending that you should touch the clock part during the fixing of the hold and the setup violation. So let's start with that, and we will start with the flip-flop 5 and flip-flop 6. So let us suppose that there is a hold violation within this path. So this is a timing path Q5 to Q6, and as I mentioned that you want to fix that hold violation with the help of the skew only. So skew only in the sense that you want to touch the clock network. So the point is if you want to do that, how can we fix this violation? So as we have discussed in the previous lecture that there is a relationship between the hold and the skew. So if you will increase the skew, then there are chances that your circuit violate with the hold violation. And so if you want to fix the hold violation, so you have the very simple technique that you just decrease the skew with this path. So this is the clock 6 and this is the clock 5. So I would say you just decrease the skew within this path. So how can you decrease the skew? So basically here in this path you can see that there are three ways. Either you remove this buffer, that is the one option. The second option is you can also remove this particular buffer. And the third option is you can just keep this path as it is, and you can just add one buffer here. If you will remove this buffer, now you can see that delay. So let us suppose if there is no delay here, and initially there was delay of one buffer away, 1 nanosecond delay, then you can see that there are 2 nanosecond delay was there. Now if you will remove this, there is a delay of 1 nanosecond. That means you decrease the skew. So if you will decrease the skew, obviously the hold violation is fixed. The second method is, in place of removing this, you can add one buffer here also. So relatively you can see that in place of removing this buffer and decrease the delay from 2 nanosecond to 1 nanosecond. So what exactly you are doing? So there are two ways that if you will remove this buffer, so this technique that you remove this buffer, that definitely from 2 nanosecond the difference become 1 nanosecond. The second technique is you just keep this buffer as it is and you just add one buffer here. It is also the, let us suppose, the 1 nanosecond. So difference of this is again as a from the 2 nanosecond you decrease it in the 1 nanosecond. This is the two second option. The third one is you don't touch, you don't add here anything, you don't remove this one, you can remove this particular buffer also. So same thing, that either you can remove this buffer or you can remove this buffer or you can add one buffer here. So you have these options when you are fixing the hold violation. Similarly, if you have to fix the setup violation, so in place of decreasing the skew, you can increase the skew, and if you want to increase the skew, definitely either you just, if there is any buffer here, so you can remove that buffer, you can add one more buffer in this path, you can add one more buffer in this path. So in this way you can fix your setup violation. You come to know that okay, how we can fix the hold of the setup violation. So the next question will come that what is the implication of this particular method. Let's take one by one. So the first one is you remove this particular buffer. So just remember, like right now there is a buffer, and I'm saying that there is no setup and hold violation in the whole circuit. So that means in this circuit also there is no setup and hold violation. In this path, the skew is, let us suppose this is a 1 nanosecond and this 2 nanosecond. That means the skew is 1 nanosecond, and there is no setup and hold violation. So if you will remove this particular buffer, so what is going to happen? Now this 1 nanosecond skew, that is going to increase 2 nanosecond. And as we already discussed, that if you increase the skew, what will happen? There are possibility that there will be the hold violation. So what you have done, that just removing this buffer, it can fix the hold violation in this between the FF5 and FF6, but there are chances that it will violate this particular path. So you fix the hold violation here, but this path now violating the hold check. So that is the one drawback of removing the buffer here. So now what you will do, you will say that okay, you will not remove this particular buffer and you will add one buffer here. So it is going to solve the same purpose. That means in this path you are decreasing from 2 nanosecond to 1 nanosecond, and there is a no change here. So there is no change here, it is still a 1 nanosecond. But what will happen to this path? Initially there is no buffer here. That means the difference between this path is 1 nanosecond. So if I am talking about this, the skew within this path is 1 nanosecond. The moment you added this, that means you increase the skew here, and if you increase the skew here, what will happen? There are chances that this particular path violate the hold violation. That means this option is also not recommended. This is one of the reason that we never recommend to add or remove the clock buffer which is very next to the clock 6. So never, we always ignore this approach. We don't want to add a buffer here, or we if let us suppose the buffer is here, then we don't want to remove this buffer here, because it may fix your hold violation or the setup violation, that particular path, but it can affect the another path. So now the thing is that in place of removing this buffer, so if you are removing this buffer, that is not going to solve our problem. So we can say that don't remove this one and don't add any buffer here. So you can touch this buffer, which is like a buffer bar. So what is going to happen? Now if you will remove this particular buffer, then the skew will decrease in this particular path. So from 2 to 1. Now since for this particular path, this it is more important that what is the skew here, this buffer is common for clock 6 and the clock 7. It is not going to affect this timing path. This buffer is outside the timing path of between the clock FF4 and FF5. This is outside this, so it is not going to affect this timing path also. So you can say that this is the right approach. Okay, now we got it. Let me just summarize the thing, that if you want to fix the hold or the setup violation, so what you have to do, if you want to fix the hold violation, you want to decrease the skew. So for decreasing the skew, in this particular scenario you had three options, like remove this particular buffer, or you can add one buffer here, or you can remove this particular buffer. In the setup it will be the reverse. So as we just discussed, that if you will add any buffer here, it will affect the timing path between the FF4 and FF5, because the skew will increase. So that means there are chances that there will be the hold violation. Similarly, if you will remove this particular buffer, again you are increasing the skew in this path, and there are chances that this path will have a hold violation. So the right approach is that you will always either add or remove the buffer from this common clock path. So for this common clock path, in the sense this path is common for the next stage, and this path is not going to come into the previous stage, so there is no problem. In the next lecture, we will discuss that what are the different complications if we will add this particular buffer in this place. Like an example, like let us suppose that if your circuit have something similar to this, so what will happen? Similarly, there are other complications in the circuits also. We will discuss that part in the next lecture.